She had done everything exactly the way she was told. Every pill taken on schedule, every portion measured carefully, white bread replaced with whole grain, desserts removed completely, walks 3 times a week, even on days when exhaustion sat heavy in her legs. And still, when her latest blood work came back, the result hit like a punch to the chest. Her HbA1c, the number that reflects average blood sugar over the past 3 months, was 8.1%. Still dangerously high. Still deep in diabetic territory. I remember the look on her face when she sat across from me. It was not fear. It was something far heavier than that. It was frustration. The kind of frustration that comes when you followed every instruction, made every sacrifice, and yet your body refuses to respond. She quietly listed everything she had been doing to control her diabetes, almost as if she were defending herself. And as she spoke, I realized something that I have seen far too often over years of medical practice. The problem wasn't that she wasn't trying. The problem was that she had only been given half the picture. This happens more than most people realize. The standard advice for type 2 diabetes is familiar. Eat fewer carbohydrates. Lose weight. Take your medications. Exercise more. And while none of this is wrong, it is incomplete. Because diabetes is not simply about how much sugar enters your body. It is about what your body does with that sugar after it arrives. And that is where most people are left in the dark. What many patients are never told is that blood sugar control is governed by an incredibly complex biological network involving hormones, receptors, enzymes, muscle tissue, gut signaling, sleep cycles, and cellular energy sensors. If you only focus on food restriction, you are trying to solve a multidimensional problem with a single tool. That is why so many people work incredibly hard and still struggle. And that is exactly why this matters. Because when people understand the mechanisms happening inside their body, something shifts. The process becomes less about blind discipline and more about strategic action. Today, we're going to explore 6 scientifically supported remedies that can help improve blood sugar control. Not myths, not internet gimmicks, not miracle cure. Real interventions grounded in biological science. Each one targets a specific weakness in the body's glucose management system. Some work through the digestive tract. Some directly influence cellular glucose transport. Others affect hormone regulation while you sleep. And one of them activates a glucose-lowering pathway so powerful that it bypasses insulin resistance entirely. That means even if your cells have become resistant to insulin, this pathway can still move glucose out of your bloodstream. And if you stay with me, I'll explain exactly how it works. But before we get there, there is something crucial to understand. When I say remedy, I do not mean cure. There is no magical solution that instantly reverses diabetes overnight. Anyone promising that is selling fiction. What I mean are targeted physiological interventions. Specific actions that improve how your body handles glucose at the cellular level. These remedies work alongside proper medical treatment. They are not replacements for prescribed medications. They are enhancements to the biological systems already working inside you. And once you understand them, you begin to see blood sugar management in a completely different way. The first remedy may surprise you, because it involves something sitting in kitchens around the world. Something many people dismiss as just another wellness trend. Apple cider vinegar. Now before you roll your eyes, let's separate science from hype. This has nothing to do with detoxes. Nothing to do with miracle cleanses. The active compound we care about is acetic acid, and its effect on blood sugar is rooted in 2 very specific biological mechanisms. The first mechanism begins in your stomach. When diluted acetic acid is consumed before a meal, it slows gastric emptying. That means food leaves the stomach more slowly and enters the small intestine at a reduced rate. Why does that matter? Because your small intestine is where carbohydrates are broken down into glucose and absorbed into your bloodstream. When this process slows down, glucose enters your blood more gradually. Instead of a sudden spike, you get a slower, flatter rise. That matters because sharp post-meal glucose spikes create oxidative stress. Over time, repeated spikes damage blood vessels, strain insulin-producing cells, and accelerate diabetic complications. But acetic acid doesn't stop there. Its second mechanism is even more fascinating, and it involves one of the most powerful blood sugar regulating hormones in the human body. A hormone so important that entire classes of modern diabetes medications were built to mimic it. And that is exactly where remedy number 1 becomes far more powerful than most people realize. In part 2, we'll break down how this hormone works, the exact protocol for using acetic acid safely, and why the sequence of what you eat may matter just as much as what you eat itself. Before you continue, subscribe to the channel and turn on notifications, because understanding this next mechanism could completely change the way you approach blood sugar control. That hormone is called GLP-1. And if that name sounds familiar, it's because some of the most powerful modern diabetes and weight loss medications are built around it. But long before it became a pharmaceutical breakthrough, it was already part of your biology, working quietly, responding to what you eat, regulating how your body handles glucose in real time. GLP-1, or glucagon-like peptide 1, is released by specialized cells lining your small intestine when food enters your digestive system. Its job is precise and powerful. It signals your pancreas to release insulin, but only when glucose levels are rising. Not constantly, not excessively, only when needed. This is what's known as glucose-dependent insulin release. And it matters because it keeps your system balanced. When blood sugar rises, GLP-1 amplifies insulin. When blood sugar falls, it backs off. No overcorrection, no crash. At the same time, GLP-1 suppresses glucagon, the hormone that tells your liver to release stored glucose. So you have a dual effect happening at once. More insulin when needed, less unnecessary glucose release. That combination is incredibly effective at controlling post-meal blood sugar. Now, here's where acetic acid becomes relevant. Research shows that consuming acetic acid before a meal can stimulate the release of GLP-1. Not at pharmaceutical levels, but enough to create a measurable biological effect. Which means something as simple as this can help your body respond more intelligently to the food you're about to eat. This is not a hack, it's a signal. A way of preparing your internal system before glucose even enters your bloodstream. And when you combine both mechanisms, slower gastric emptying and enhanced GLP-1, signaling the result is a significantly reduced blood sugar spike after meals. In controlled studies, this reduction has ranged between 20 to 35%. That is not small. That is clinically meaningful. Now let's talk about how to actually use this. The protocol is simple. 1 to 2 tablespoons of apple cider vinegar, diluted in a full glass of water. Taken about 10 to 15 minutes before your largest meal of the day. Never take it undiluted. Acetic acid is corrosive and can damage tooth enamel and irritate the esophagus. Dilution is not optional. And just as important, this is not a standalone fix. It works best as part of a broader strategy. Think of it as priming the system, preparing your body to handle what's coming next. Because what comes next matters more than most people realize. And that brings us to the second remedy. One of the most overlooked, yet incredibly powerful tools in blood sugar control. It has nothing to do with cutting foods, nothing to do with removing carbs. In fact, it doesn't even require changing what you eat, only the order in which you eat it. This is called meal sequencing, and it may be one of the simplest ways to dramatically reduce post-meal glucose spikes. Here's the concept. When you eat carbohydrates on an empty stomach, they are rapidly broken down into glucose and absorbed quickly. This leads to a sharp spike in blood sugar. But when you eat fiber, protein, or fats before carbohydrates, something different happens. These components slow digestion. They form a kind of physical and biochemical barrier in the digestive tract. So when carbohydrates finally arrive, their absorption is delayed. Glucose enters the bloodstream more slowly, and the spike is significantly reduced. But it's not just about digestion speed. Eating fiber and protein first also triggers early hormonal responses, including insulin and GLP-1, before carbohydrates even hit your system. So, by the time glucose begins to rise, your body is already prepared to manage it. It's a completely different metabolic environment, same meal, different outcome. Studies have shown that simply changing the order of food consumption within a meal can reduce post-meal glucose spikes by up to 30–50%, without reducing portion size, without eliminating carbohydrates, just by changing sequence. Here's how it looks in practice. Start your meal with vegetables, especially fibrous ones, leafy greens, broccoli, cucumbers. Then move to protein and fats, eggs, chicken, fish, legumes. and finish with carbohydrates, rice, bread, potatoes, or dessert. You're not removing anything. You're restructuring the order. And that small shift creates a powerful metabolic advantage. Now think about how most people eat. Carbs first, bread before the meal, rice as the base, dessert immediately after. It's the exact opposite of what your biology handles best. And once you see this, you can't unsee it. Because suddenly, you realize that blood sugar control isn't just about restriction. It's about timing, sequence, preparation, which leads directly into the next remedy. Because even if you've optimized what you eat, even if you've optimized the order you eat it in, there is still a moment, a narrow window after your meal where your body is most vulnerable to glucose spikes and also most responsive to intervention. Most people miss this window completely. They sit down, they rest, they scroll. But there is something incredibly simple you can do during this time. Something that activates a glucose-lowering pathway your insulin resistance cannot block. And it only takes 10 minutes. There is a moment after every meal that most people completely waste. A small window of time where your body is actively processing glucose, deciding where it goes, how long it stays in your bloodstream, and how much damage it might do. And in that window, something remarkable becomes possible. Because your muscles have the ability to pull glucose out of your blood without needing insulin at all. Let me explain. Most people think glucose enters cells through a single pathway. Insulin rises, binds to receptors on the surface of your cells, and signals glucose transporters, specifically GLUT4, to move to the cell membrane and absorb glucose. That's the standard pathway. And it works well, until it doesn't. In type 2 diabetes, this pathway becomes impaired. The receptors become less responsive. The signaling weakens. GLUT4 doesn't move efficiently, and glucose starts to build up in the bloodstream. That's insulin resistance. But here's what almost no one tells you. There is a second pathway, a completely separate mechanism that also moves GLUT4 to the cell surface. And this one does not depend on insulin. It is triggered by muscle contraction. When your muscles contract, even during something as simple as walking, they activate an internal energy sensor called AMPK. Think of AMPK as your cell's emergency response system. When it senses increased energy demand, it flips a switch. It tells your cells, we need fuel, now. And in response, GLUT4 transporters are pulled to the cell surface, independently of insulin, which means glucose can enter your muscle cells even if insulin signaling is impaired. This is not theoretical. This is a well-documented physiological process. And for someone with insulin resistance, it is a direct workaround to the problem. Now, let's connect this to timing. After you eat, your blood glucose begins to rise. It typically peaks somewhere between 30 to 45 minutes after the start of the meal. That is the moment when glucose concentration in your bloodstream is at its highest. And if you do nothing, much of that glucose lingers, circulating, damaging, straining your metabolic system. But if you introduce muscle contraction during this exact window, you change the outcome completely. A brisk 10-minute walk, started about 10 to 15 minutes after finishing your meal, aligns perfectly with that glucose peak. Your muscles begin contracting just as glucose levels are rising. AMPK is activated. GLUT4 transporters move to the surface. And glucose is pulled directly into your muscle cells where it is used for energy instead of remaining in your bloodstream. Same meal, same body, different result. Because of timing, this is why not all exercise is equal. A 30-minute walk in the morning before breakfast is beneficial, yes, but it does not interact with post-meal glucose in the same way. It does not target the spike, and studies have shown something very specific. 3 short 10-minute walks taken after meals are more effective at lowering 2 4-hour average blood glucose than 1 continuous 30-minute walk done earlier in the day. Same total duration. Completely different biological impact, because the body rewards precision, not just effort. And yet, what do most people do after eating? They sit, they relax, they scroll on their phone, exactly when their body needs movement the most. This doesn't require a gym. It doesn't require intensity. It doesn't require perfect fitness. Just a simple walk, 10 minutes, at the right time. Now imagine combining this with what you've already learned. You slow glucose entry with acetic acid. You reduce spikes through meal sequencing. And then you actively pull glucose out of the bloodstream through muscle contraction. You're no longer reacting to blood sugar. You're directing it. But we're not done. Because inside your cells, there is another layer of control. A master switch that governs how your body produces, uses, and stores energy. The same switch that was activated when your muscles contracted during that walk. And there is a compound derived from plants that can activate this switch even when you are at rest. It targets the liver, the muscles, and the very pathways that medications like metformin are designed to influence. This is where things get even more interesting, because this next remedy doesn't just assist your body. It changes how your metabolism behaves at a fundamental level. Now we move deeper, because everything we've talked about so far, slowing glucose entry, sequencing meals, post-meal movement, all of it operates on the surface level of control. Important, yes. But underneath all of that, there is a central command system, a master metabolic switch that determines whether your body burns energy, stores it, or releases more glucose into the bloodstream. That switch is called AMPK. You've already seen it once. It was activated when your muscles contracted during that 1-0-minute walk. But here's where things become even more powerful. There are compounds that can activate this same pathway even when you're not moving. And one of the most studied among them is berberine. Berberine is a plant-derived compound that has been used for centuries in traditional medicine. But modern research began paying close attention to it when something unexpected showed up in clinical studies. Its effects on blood sugar started to look very familiar, because berberine doesn't work randomly. It targets specific metabolic pathways. When it activates AMPK, 3 major things happen inside your body. First, your liver reduces glucose production. This matters because your liver is constantly releasing glucose into your bloodstream, even when you're not eating. In people with type 2 diabetes, this process called gluconeogenesis is often overactive. Berberine helps suppress it. Second, your cells become more sensitive to insulin. Muscle and liver cells respond more effectively, meaning glucose can enter more easily. Third, it promotes GLUT4 translocation, the same mechanism you saw with muscle contraction. More glucose transporters move to the cell surface, pulling glucose out of the bloodstream. Now here's why this caught researchers off guard. These are the same 3 primary mechanisms targeted by one of the most widely prescribed diabetes medications in the world, metformin. And in multiple controlled studies, berberine produced comparable improvements in fasting glucose and HbA1c over a 1-2 week period. That doesn't mean they are interchangeable, and it's important to be very clear about that. Metformin has decades of safety data, standardized dosing, and medical supervision. Berberine supplements, on the other hand, vary widely in quality and absorption. So this is not about replacing medication. This is about understanding the mechanism. Because once you understand AMPK, you start seeing the bigger picture. You realize that your body is not passive in this process. It is constantly making decisions about energy, and certain actions like movement, nutrition timing, and targeted compounds can influence those decisions. But even with all of this, something can still quietly undermine the entire system. Something most people completely overlook, a deficiency that interferes directly with insulin signaling itself. That missing piece is magnesium. Magnesium is not optional in your body. It is required. At a cellular level, it acts as a cofactor for the insulin receptor. Think of it this way. Insulin is the key. The receptor is the lock. But magnesium is what allows the lock to actually turn. Without it, even if insulin binds perfectly, the signal doesn't transmit efficiently. And here's the problem. A large percentage of adults don't get enough magnesium. And in people with diabetes, the situation is even worse, because high blood sugar causes the body to lose more magnesium through the kidneys. So the condition itself worsens the deficiency that makes it harder to control. A cycle. Quiet. Progressive. And often missed. Studies have shown that increasing magnesium intake can improve fasting glucose, insulin levels, and overall insulin sensitivity. Not dramatically overnight, but meaningfully over time. And you don't always need supplements to start. Dark leafy greens, pumpkin seeds, legumes, newts. These are foundational sources. If supplementation is considered, Forms like magnesium, glycinate, or malate are generally better absorbed and gentler on digestion. But again, this is a conversation with your doctor, because the goal is not to guess. The goal is to correct. Now we arrive at the final piece, and in many ways, the most powerful one, because it happens every single night, or at least it's supposed to. Deep sleep. This is where your body resets, not just mentally, but metabolically. During deep, slow-wave sleep, several critical things happen at once. Cortisol, the stress hormone that raises blood sugar, drops to its lowest level. Growth hormone is released. Cellular repair processes activate, and your body recalibrates its insulin sensitivity for the next day. But when sleep is poor, fragmented, cut short, that entire system breaks down. Cortisol stays elevated. Your liver continues producing glucose overnight, and your cells become more resistant to insulin the next morning. One study showed that a single night of poor sleep can reduce insulin sensitivity by up to 25%. One night, not weeks, not months. One. That's the metabolic weight of it. And then there's something called the dawn phenomenon, a natural rise in blood sugar that begins early in the morning as cortisol increases to wake your body up. In a healthy system, this is controlled. In an impaired system, it leads to elevated morning glucose before you've even eaten. And poor sleep makes it worse. So this is not just about getting more rest. It's about protecting deep sleep specifically. And that comes down to a few key factors. Consistent sleep timing, a cool, dark environment, avoiding alcohol before bed, because alcohol may help you fall asleep, but it disrupts the deeper stages that your metabolism depends on. Now step back and look at everything together. These 6 remedies are not random tips. They are targeted interventions. Each one addresses a specific breakdown in how your body handles glucose. Acetic acid slows glucose entry and primes hormonal response. Meal sequencing prepares your system before carbs arrive. Post-meal walking by passes insulin resistance. Berberine activates your metabolic master switch. Magnesium restores the function of insulin signaling. And deep sleep resets the entire system overnight. This is the full picture. Not just controlling what goes into your body, but improving how your body responds to it. Because that is the difference. Anyone can restrict, but understanding gives you leverage. And leverage changes outcomes. If this helped you see your body differently, if even one of these mechanisms made something click, then don't keep this to yourself. Subscribe to the channel, share this with someone who needs it, and start applying even one of these today, because small, informed changes repeated daily can completely transform how your body handles blood sugar over time.